All right, hello everyone. Welcome to the Keys to Making Computational Storage Work in Your Applications panel. My name is Jason Molgard and I am a Principal Storage Solutions Architect at ARM, and I'm also the co-chair of the SNIA Computational Storage Technical Working Group. I will be the moderator for this panel. Our panelists are Stephen Bates from Eideticom, Scott Shadley from NGD Systems, and Tong Zhang from ScaleFlux, all of whom are working on various computational storage products and solutions. So I'm going to start with a question, and if everyone out there has some questions, if you can go ahead and type it into the Q&A window, then we'll be glad to answer those. But to begin, panelists, maybe you can introduce yourselves and tell us why you think computational storage is important. So Stephen, do you want to go first?
Sure. Hi, everyone. Welcome to Virtual Flash Memory Summit. My name is Stephen Bates. I'm the Chief Technology Officer of Eideticom, which is a computational storage startup. I'm also the co-chair of the NVMe task group on computational storage, where we're standardizing NVMe to understand computational storage. And I believe computational storage is important and its time has come, because with the advent of Flash, we are now in a world where data can move a lot faster than our processors can accommodate. And we've opened up new bottlenecks in computer architecture where we really want to put efficient computation as close to the data as possible. But we want to do that in a vendor-neutral, standards-based, open source software way. And I believe computational storage, as is being standardized by SNIA and NVMe, is the right way to get us there.
Great, thank you, Stephen. So Scott, I'll just pick randomly. You want to go next?
Sure, why not? Thanks, Jason. So my name's Scott Shadley. I'm the VP of Marketing here at NGD Systems. I thought it'd be fun to be outside the building today. So this is sunny SoCal, where we're headquartered. I'm also the co-chair, along with Jason, of the Computational Storage Technical Working Group within SNIA, and I sit on the board of directors of SNIA as well. I agree with everything that Stephen said. It is the time and place now for computational storage to take over and kind of add the value that needs to be added to the technology stack that we have today. We've looked at storage as a placeholder for a very long time. It's time to let storage do a little more than just hold the data and then allow it to do some unique and new and innovative things with that data. And that's concepts that we see from a computational storage point of view that can include things like AI, ML, compression, and other types of filtering applications. I'm very excited to see what we can do with this technology as we move forward. I'm looking forward to the conversation.
Great, thank you, Scott. All right, Tong, sorry, certainly not least, but thank you.
Thank you, Jason. Hi, everyone. Yeah, I'm Tong Zhang, the co-founder and the chief scientist at ScaleFlux. And also, I'm also currently a professor at Rensselaer Polytechnic Institute, or RPI, at Troy, New York. So at ScaleFlux, we're really kind of fully confident about the importance of the bright future of computational storage, simply for just the two reasons. First, in theory, it just makes perfect sense. It's just naturally aligned to the inevitable trend toward heterogeneous computing. And two, by already shipping tens of thousands of computational storage drives, we have firsthand witnessed how computational storage could bring significant value to our end customers. Given our current product and the next generation product, we are clearly see a very wide open door for computational storage drive to enter mainstream market and bring huge cost and performance benefits. So really, in summary, computational storage, first, in theory, it makes a perfect sense. Second, in practice, we ourselves have witnessed its big value to many real customers already. Yeah, so that's it.
Great. All right. Thank you, everyone. Thank you for the introductions. And the first question, I'm not seeing any questions from the audience yet. So audience, if you have some questions, please type it into your chat window and we'd love to answer them. So while we're waiting for that, maybe we can move on to a question that I have. So what are the key challenges of architecting and implementing a commercially viable computational storage product? So Tong, maybe we'll go in reverse order this time. You want to go first on that one?
Oh yeah, sure. We know that today we are still in the very early stage of computational storage as a new emerging thing. So one key challenge we have seen is that how to enable the existing software ecosystem to seamlessly embrace the new computational storage hardware. Actually, to be honest, not many engineers are willing to change their a single line of code or upgrade server for a new, really unknown storage hardware, right? So then we have to be honest on this aspect. So this is very important, like for computational storage, to transparently as possible to benefit the upper level user application software. So that is our view on the key challenge.
Scott?
Yeah, so I would agree with Tong from this point of view that it needs to be something that is embraced by a larger than just the startups that make it. We've seen lots of new technologies that come to market that get challenged because they don't have that traction. That's one reason why exactly 3 years ago at FMS 2018, a lot of us that are on this panel even sat down in a meeting and said, let's standardize this effort and make it viable for everyone to use and take that technology forward. So kind of the birth of the computational storage standardization work that takes place now in SNIA and NVMe was at FMS 2018, and we're looking forward to continuing to drive that. Additionally, things like doing a lot of research has been a part of this. I mean, the concepts of computational storage have been out in the market since 2012, 2013. Various different papers have been written on it constantly about how to do it. It's been a lot of academic work, even some recently released papers that around heterogeneous architectures like Colin was talking about. And then next, the next level of that is to get the traction with the larger organizations that deliver our products to end customers, because we're a piece of a very large pie, and we need to make sure that we holistically make that pie viable for the end consumers in the marketplace.
Great, thanks. Stephen.
So I'm going to echo what my co-panelists have said, but I like to sum it up in a phrase that my marketing team hate when I use it. And what we really have to do is make computational storage consumable by idiots. And what I mean by that is creating an ecosystem that involves open standards, vendor neutrality, and open source software that allows the end consumers of computational storage to feel comfortable in making their purchasing decisions. And also, to Scott's point, having the data, whether it's from academia or white papers or from real world deployments, that shows real value proposition for computational storage. So the end consumers can feel comfortable about their purchases and know that they're getting value for money.
Great, thank you for that. All right, so I'm starting to see some questions come in from the audience. So thank you, audience. Please keep sending the questions. So we can start with the first one that's come in. What is each of your company's biggest win so far? I don't know to what degree you can explore that, but you know, please, whatever you can share. I'm sure people are very curious. Who wants to go first on that one? I'll pick Scott this time since you didn't go first either the other two times.
Well, you're so very kind. I appreciate that. Yeah, so to your point, there are a lot of things around what we're doing that tends to be, you know, still NDA level type of conversations. But our actual biggest win to date has to do with edge computing and edge deployments. There's been a lot of talk in the market today around autonomous everything. And our single largest win right now, as far as volume deployments, is related to a prime that delivers to the autonomous car market. So we're actually providing the storage and the compute offload capabilities in the in-trunk storage device via our M.2 based modules. So the fact that we have the ASIC based solution has proven the value to that customer since they have a confined space and a limited power volume.
Great. Tong.
Yeah, up to date, like our biggest one is really kind of the work we have been working with Alibaba Cloud. We have really over the 2 years kind of collaboration with Alibaba Cloud. We have very successfully develop and deploy the computational storage drive that can be seamlessly integrated in their cloud native database platform that can achieve like over 10 times performance again for their data like data analytics workload. And also meanwhile, like we're also pushing for this kind of computational storage drive with transparent compression that can again seamlessly deployed for virtually all the like relational database systems. So that is also like one of our directions. We see tremendous interest from big customer and the small customers. Is really kind of we see really a huge demand for this kind of computational storage drive with transparent compression. Yeah.
Great, Stephen.
Yeah, I'm gonna cheat a little and talk about three things. So one is the customer wins. From a public facing point of view, I can talk about our win at Los Alamos National Labs, where we are accelerating a massively parallel file system by providing some of the storage services like compression and erasure coding, offloading the processors, and making that system much more performant and much more cost efficient. We have some other design wins I can't talk about, but that one we can talk about publicly. I think the biggest win for me on the ecosystem side has been the adoption of computational storage within NVMe. So NVMe is just going gangbusters right now. It's a performant protocol for Flash that's, you know, to be honest, I've always seen that as a really, really good protocol for computational storage. And I'm super excited by the fact NVMe has voted to standardize computational storage within NVMe. And if you had a chance, Amber Huffman, the president of NVMe, just gave a keynote at Flash Memory Summit, and she spent some time talking about the vision that we have for computational storage there. So that's also really, really important. And then on the on the software side, I think some of the work that SNIA is doing around APIs for computational storage, again, vendor neutral open standard, is really, really important, again, from the adoption point of view.
Thank you, Stephen. Yep, appreciate that. So a couple additional questions have come in, so maybe we can try this one. With all of the various workloads, will there ever be a single metric or tool to benchmark performance and compare implementations? So Stephen, this actually kind of ties in with what you were just saying. So maybe you want to...
That's a great, great question. So I think some of the figures of merit that computational storage companies, including my own, are really emphasizing are things like total cost of ownership. So we kind of compare what it means for a customer to run, for example, a ScaleFlux database for 3 years using a traditional storage architecture based on Intel or AMD processors without a computational storage acceleration capability. And we compare that to what they get if they add computational storage products from one of us into that system. And again, I think to Scott's earlier point, this is an area where there's still a lot of work to be done, because convincing the end consumer that there is a value proposition is not always trivial. And the analysis to show that value proposition is not always simple. So there is a need, I think, for more work to be done within companies like ours, within standards bodies like SNIA and NVMe, and within academia to show that there is real value in terms of figures of merit like TCO, like performance metrics, like 99th percentile latency, other performance metrics when you deploy computational storage. So that's an area that I think there's still work to be done in.
Yeah. Oh, and also I agree that really, I think like computational storage really is not a one type of product. It's really kind of one category of a diverse kind of a type of products. So really kind of different products that target on different market, different segment, even totally different applications. So then for the metrics, really should be like a market and application specific. And overall, I think really, I really echo Steven's point of view, like the cost, the total ownership of the cost is really one of the very critical metric. I mean, regardless of specific applications, especially as today, as the technology scaling is slowing down on both CPU and the flash memory. So then really it is increasingly important to improve the overall hardware cost efficiency. So then really we believe the computational storage should have a big play over there to improve the cost efficiency.
Yeah, and I'll again continue to echo my coworkers or colleagues on those spaces. But I think another thing to look at is, to Tom's point, it's not a one-stop shop. This is not something like, oh, it's NVMe versus SATA. This is a whole new category of technology and implementations, and the ability to manage the TCO that's applicable to what that customer or consumer is looking for. So, for example, Alibaba Cloud from ScaleFlux, Los Alamos from Eideticom, our autonomous cars, they're all doing different things with these types of solutions, and the value that each of them bring is somewhat unique to those customers. And people are looking at it, we can't do this as a dollar per gigabyte or a number of IOPS or gigabytes per second type of metric that we're used to for storage products. This is a compute level solution where we're looking at the overall system. So if I'm offloading work being done by the host processor and allowing it to do other things, like AI or machine learning, or even something as simple as a search, so that CPU can go do other more valuable work, or sending smaller amounts of data out of storage into a GPU, so the GPU resources are being more properly utilized. Those are the things that people are starting to wrap their heads around and go, oh, wow, that's really cool. Because at one point, people thought we were competing with GPUs or even the new quote, DPUs that are out there. We're not. We're creating an architecture that actually makes those solutions more valuable. And it's a total cost play in a lot of different metrics.
So well stated, panelists. Thank you for that. So there's a couple of questions that have come in. Let me try to condense this down a little bit. The first part was, who decides whether a compression algorithm is run on the system, the user or the system? And then part two is how to decide which algorithms, such as the compression or erasure coding or encryption, that you'd put on a CSD. So go ahead, Tong.
Yes, regarding compression, really, I think the user, like normal customers, will really prefer that they do not need to vary compression at all. They just run like a MySQL Oracle without varying, even without turning on the compression. Then the compression work can be handled completely inside the computational storage and completely transparent to the upper host, upper level host OS and those user applications. So that is kind of and then regarding which particular algorithm, then that is totally up to the vendor, up to the computational storage vendor. They decide to do whether they want to implement a gzip or the standard or LZ4, then they totally transparent. Really kind of so then from end user perspective, they only see the difference in terms of achievable compression ratio, but they don't feel spending any CPU cycles on doing the compression and managing those variable lengths data chunks. And so then suddenly for the encryption, then should be a kind of different story. Then we should follow this kind of standardized way, AES, those to do the, but again, that people should prefer those transparent, those kind of compression encryption, just as transparent as possible.
Yeah, and to add on to that comment, so that's part of the ideas behind what Computational Storage Working Group is doing in SNIA around this idea of a computational storage function. I mean, we've had this, the previous terms we were using was a computational storage service, and it allowed a customer or a user to choose either a fixed feature set or a programmable feature set, and there's configuration options within those. Again, however much the customer wants the access to it is what the customer should be provided access. There are certainly ways to hide it, if you will, from a transparency perspective, and there's solutions on the market that do that today. There was a great talk earlier in A9 session from Andy Walls about how IBM is doing a transparent compression version of a computational storage like workload. There's also examples of ways we can make it more user-friendly and say, I don't want to actually force you something. I want you to take a copy of what you're going to run normally in your CPU, drop it in my device, and I will execute it as if I were your host. So there's multiple ways we can do it, and it should be flexible enough to allow the customer that choice.
Yeah, and I think one of the things we've definitely seen is customers are very interested in open algorithms that, if, for example, the computational storage devices, heaven forbid, to fail, there's still the ability to access data because there's no proprietary manipulation of the data done. And what I mean by that is, as Tom said, aligning with standards like zlib, LZ77, and so on and so forth. I think the other thing that I'll say is we're starting to see some of these storage-centric services like compression, encryption, really become the table stakes for computational storage. They're almost like the must-haves even to be at the table. And what we're really starting to see, and this is true within SNIA and NVMe, is that we're moving beyond the table stake functions and getting more into some of the, what I would say are more interesting things like running eBPF programs, pushing Docker containers down to devices, specifying FPGA bit files that can be pushed from the host of the device to do specific things. And I think that's a really interesting step that we're just starting to get into from a standardization perspective. So some companies are already doing some of this, but it's all very vendor specific right now. And I think it's a very exciting time for computational storage because we are now going, all right, we've got the meat and potatoes done, for want of a better word. Now, how do we start looking at the really interesting stuff that really could accelerate an application like a database or an image detection framework or a big data warehouse deployment?
Great. So Tong, a follow-up question that was asked from your discussion just a moment ago. Is there a CSD used in a real Hadoop production system? Hadoop does a lot of compression, and this seems like it could be easily offloaded.
Yes, actually now, like most our deployment is more like on a relational database, like MySQL, MariaDB, Postgre, and Oracle. Compared with Hadoop, but I mean that is, I think, one of the reasons. Because certainly Hadoop can certainly benefit from this kind of transparent compression, but compared with those Hadoop systems, those relational database users, they are more willing to invest new hardware to improve their cost efficiency, to improve their performance, and so then. Really compared with this Hadoop, like Hadoop ecosystem. And also, meanwhile, like a Hadoop ecosystem, they tend to compress data in relatively large block, like a couple hundred kilobytes or megabytes. So then in that case, then transparent compression, to be honest, transparent compression may not be the best, the best solution. So. Yeah, because our current product really tied into transparent compression, even though like our next generation product can handle both transparent, like on 4K byte per 4K byte transparent compression and much larger granularity on the compression side. Yeah, so that will provide a much better value proposition for like a Hadoop, those kind of ecosystem.
So if I may add to that as well, compression, again, is very valuable. It's a wonderful feature that these devices are able to offload quite considerably and quickly. We've actually done some work in Hadoop in the past with some very large hyperscale customers, and ours was focused not around the compression, but around how to offload the actual applications, the simple applications. So take word count or TerraSort, two very similar, but very easy to implement inside a CSD offload options of Hadoop. And we ran those very quickly, efficiently, and saved power and all those things. The data compression was part of that access to the devices. It wasn't the focus of it. So this is getting above just the compression layer, but actually looking at the actual application pieces of the Hadoop workloads that we can also push further down into these devices. So think about doing simple thing like word count across 24 drives, 24 CPUs instead of a single CPU trying to look through 24 drives. It's very simple math to add value to why this technology like computational storage is of value.
I also forgot to mention that actually in the context of this Hadoop ecosystem, actually we are pursuing this kind of, because Hadoop system can tend to accelerate using a cache. So actually now we are exploring along that direction as well. Using current transparent compression to accelerate the cache for Hadoop. Yeah. So yeah, so that is one like a more like a better low hanging fruit in the context of Hadoop.
All right, great. Audience, please continue to send in your questions. So here's another one that came in. Which functions do you think can provide the greatest value for database users and data centers? Which functions add the most value in edge or IoT applications?
So I'll go ahead and throw out one there for you. We did a recent research project that was involved with Microsoft, and it's not a customer, it is a Microsoft research project. So I didn't put it as a win, if you will, but we took an implementation of a Facebook open source AI application that did what's called image similarity search. We deployed it on a 1 billion image database that Microsoft can figure out how to search through more efficiently and deployed it across our devices. And it was actually written in a paper that I just posted into the chat window on Whova that people can go take a look at. And it shows cases exactly how offloading for a data center purposes, think about Google search. What's the latest image you want to search for the day, and how do I find all the relevant images from the historical archive of data that I have in a more efficient manner? That's something the data centers care about, because Google started the whole concept of how quickly can I return a search result? Well, what's the popular image of the day? It's not always resonant in the hot patch data that's existing on those systems. So that's just something they provide as a front end to all users, not just to say, for example, a consumer of Azure or AWS. And then of course, there's database applications. We're in the process of deploying a VMware deployment around Greenplum that Stephen was kind enough to highlight in the session A9. So I'm not going to go into details on that, but that's a VMware deployment of a Greenplum database using their Tanzu platform. So there's lots of different ways you can look at it. And then the secondary part, just to close on that, Edge IoT, ingest a lot of data, move a little bit of data back. So anything you can do to analyze raw data and not have to shift raw data 100% from the Edge or IoT platforms to the host that needs the information, those are the types of workloads that are going to add value.
Yeah, I'm going to echo Scott there. I mean, on the edge, it's really about minimizing the data that has to be returned to the CO. And that's true for image, it's true for security, it's true for autonomous vehicles. Everything we're hearing from customers is, what can you do to filter data at the edge so I don't have to pay to move it up to my central office? So there we're going to see AI inference as huge. We're going to see image processing as huge. We're going to see potentially, natural voice filtering as huge. And those are going to be really, really big. And then in the data center for databases, I think we're looking more at, key value offload. There's a company called Plyops who have a keynote at FMS. They're not on this panel, but they're doing some very interesting work around computational storage for key value database offloads. I think, one of the things that Amber talked about in the NVMe talk is that within NVMe standardization for computational storage, we are going to be standardizing things like eBPF program offload. Now, those eBPF programs can be written to accelerate database search on computational storage products. And I think that's going to be a really interesting feature to have if you want to accelerate scale-out databases and scale-out big data warehouses, which are really two of the largest applications in the cloud today. So I do think there's going to be different features for edge computational storage products versus data center computational storage products. And it'll be interesting to see what companies like ours bring to market to service those different markets.
Yeah, actually for the function, like if I pick the fixed function, I would say like a compression, because really, even though the compression might sounds like pretty boring, has been started for decades. But really, fundamentally, compression is very unfriendly to CPU. When CPU carry out the compression, it will trigger a lot of cache miss. So that will make the CPU resource very severely underutilized. Actually, that is the reason why Intel only for the accelerator only has like a QAT card to accelerate compression. So and also if for the more like a flexible or programmable function, actually I totally agree with my panelist. It's really kind of data filtering, like it really kind of actually that is how what we did with Alibaba Cloud. We push the data filtering function into the drive, into the storage drive to really to filter out those kind of unneeded data before we sending that data back to the host, back to the DRAM, and then that is on its own, to just do the pre-data filtering inside the drive alone. It will just get really provide very big benefit to the whole overall Alibaba Cloud kind of data data analytics system. Yeah, so that is my choice.
All right, great. Thank you for that. Looks like we've kind of come to the end of our session time. Thank you, panelists, for all of your input and responses to the questions. And certainly you can send any of us questions through the Whova app if you have more questions, and we'll be glad to answer it. Any final thoughts from our panelists before we conclude?
I would like to tell people, if they're interested, do join SNIA, get involved, do join NVMe, get involved. Standardization is happening right now, and this is the time to get involved and help shape how computational storage is deployed.
Yeah.
Absolutely agree with Stephen on that one. We need to drive the technology forward together as an ecosystem, not as individuals.
Yeah, really, I think together we are on exploring a very, very exciting new journey together. Yeah.
Great. Thank you for that, panelists. All well stated. Thank you, everyone, for joining our session today. Have a great rest of FMS and rest of your day.
Thanks, everybody.
Thank you, everyone.
Bye.